Welcome to our presentation about Testwell CTC++, our code coverage analyzer. My name is Sabine Poehler, and at Verifysoft I'm responsible for the product management and for the service and support team here in Offenburg. During the next presentation I would like to give you more technical details about how CTC++ works. As an overview, the advantages of Testwell CTC++ are the following. You can use Testwell CTC++ for all embedded targets, and you can use it with every compiler and cross-compiler. We have several hundred customers using it on almost any possible scenario you can imagine. For these kind of developers, if you are developing on an embedded environment, then it's very important that CTC++ has a very small instrumentation overhead. On the other hand, if you are non-embedded development, it's very interesting for you that CTC++ can be used for all four languages: C, C++, Java and C#. That's a huge advantage. If you are using your coverage tool in a multi-product environment, you have one coverage tool for all your products, for all your projects, with reports you know and you can rely on, and they are always the same. Before I tell you more about CTC++ and how it works, I have a short trip to the different levels of code coverage. There's a very simple approach when you talk about code coverage. That is the idea one would have in mind to say, okay, code coverage means that everything was executed during the test. And if you translate that to a real coverage level, that would mean that you are measuring statement coverage. That is, every statement of the code was executed during the test. There is one level of coverage that is more simple than statement coverage, that is called function coverage. When you are measuring function coverage, you only have to show that every function of the program was called at least once during the test. So this measure is a very simple measure because it's not measured what is really executed or tested inside of a function, but it just counts if the function was called or not. So we come to the next step beyond statement coverage, that is decision coverage. Now we are looking at decisions, for example in if statements. And the question is, was this decision executed as false and was it executed as true during a test? After the decision coverage, it goes in two directions. There are several theoretical measures called path coverage, and these kind of measures are looking at all possible combinations of a whole path through a program. In practical life, in real life, that is not of much interest, but we are looking at the decisions with a closer look. Now we are looking at each atomic condition inside of a decision. And the question for condition coverage is if every condition, every atomic part in a decision was tested as true and as false during the test. And then one step further or two steps further, we have a multi-condition coverage level. That means that every combination of true-false evaluation was tested during their test. And there's a relaxation of the multi-condition coverage that is called modified condition decision coverage, MCDC coverage. And in the safety critical development world, MCDC coverage is the highest level of coverage that is required by the safety standards. So for example, if you are developing according to ISO 26262, you have different requirements depending on the ASIL level you are developing for. In the highest ASIL level, in the ASIL level D, MCDC coverage is required for your tests. Now I would like to give you an overview over the way CTC works in your project. Without CTC, without measuring of code coverage, that would be a kind of standard way how you work. You have your code on the left side, then you're doing your compilation or build process, you have a program, the program gets executed during your test, and you have the test result, what you are comparing with the expected result. Now CTC comes to this process. In the first step, CTC is used during the instrumentation phase. CTC consists of several tools independently from each other, and in this step the tool called CTC itself makes the instrumentation of the source code. Instrumentation means that the source code is enriched with counters, and these counters take care that it is measured later on if a certain control structure in the program was executed or not. Additionally, during the compilation and the linking phase, there is a CTC runtime added to your program. And this CTC runtime takes care in the next steps that the actual counting takes place. And the result of this counting phase is written to a special file. We call that mon.dat, but you don't take care about that in the moment. And with this information you have available during these two phases, you are able to build several kind of reports. We offer several formats as possible output format. For example, a plain TXT report, a JSON file which is structured, or an XML file, and additionally, and most important, we offer an HTML report that is the standard report for the human reader. And so every user, every tester, every developer, and also the management would use this HTML report to see the results of the coverage measurement. If we go 2 steps back now, and we're again looking at that phase where you test, where you run your tests, you have a slightly different approach when you are testing on an embedded target. Because when you're on an embedded target, you have to take care of a way to get your counting data back to the host. CTC++ offers several ways to do that. If you have a file system, for example, the test data can just be stored on that file system. If not, you are able by any communication mean that is available on your target to hand the counting data back from the embedded target to your host. And after that step, everything works as earlier. You are building the report you want, typically at the end for the user, the HTML report. Later I'm going to show you an example of this HTML report and what it shows to the reader. Earlier we talked about several levels of coverage, and now the question is, what does CTC++ measure? We have 2 phases again. During the instrumentation phase you can decide between 3 different coverage levels that are function coverage, decision coverage and multi-condition coverage. And all other coverage levels are then derived during the building of the reports. During that phase you decide if you would like to see one of the coverage level I already mentioned, function, decision or multi-condition, or if you would like to switch to MCDC coverage, for example. In every case, statement coverage comes as an additional measure to your reports. When you're reading the safety standards, then they always talk about 100% coverage, about full coverage. But in a tool or if you work on a project, it is important to have something in between 0 and 1 or 0 and 100%. So the coverage is typically measured as a percentage. And we measure a ratio between the measure points that were actually tested and all measure points that should have been tested. And this ratio is given as test effectiveness ratio in Testwell CTC++. And now we can take a look at the reports, and I would like to explain you something about them. First of all, when you switch to the report, we show an overview over every file of your source code. So after some statistical data, when the report has been generated and so on, you see an overview over every source file in your project. And for every source file, the coverage level you have chosen and the statement coverage are given. In my example, I chose MCDC coverage as structural coverage, and beside that I see the statement coverage. And the report means now, for example, when I take the first file, the regulators, that means I have 79% of MCDC coverage and 83% of statement coverage. The full coverage is shown in blue. The second file would be an example for that. And this kind of report can be seen on a file level, but also on a function level. When I go to function summary, I see the same overview, but now for every function inside a file. So here for my first file, and here we see all the functions of the second file. If you would additionally, you can make a drill down to the source code itself. If I click on any of these files, here for example the last one, I come directly to the source code, and in the source code I see detailed information about the tested and the untested parts. First of all, on the first glance you see in green and in red which parts of the code has been executed and which parts have not been executed. And then, if you would like to dig deeper, we look at one condition here, one simple if statement. In the table beside that, we have two counters. One is 0, meaning this statement has never been evaluated as true, and a 5, meaning it was evaluated to false 5 times. And then, if I scroll down a little bit, if we have a more complex decision, then it's relevant that I chose MCDC coverage for this report. In that case, with a lot of single conditions inside the complex decisions, CTC shows you a table showing every true and false combination for these conditions that is relevant. And additionally, it shows you for each condition a pair that would fulfill the MCDC condition. So it shows you, okay, for condition 1, you would have to test this combination and that combination to fulfill it. And in this case, it was tested. You see that because it's highlighted with a plus sign and it's not red. But for the third condition, that criteria was not met. It has a minus sign and it's highlighted in red. Now we saw the details. I go back to the overview you already saw, the overview over the files. Beside that, we also have an overview about the untested code. Here you can see, have a short summary about the parts of the code you have not tested. So you can decide in the report at which level you want to have feedback from CTC, what was tested and what is missing in your test cases. With that overview over the report possibilities of CTC++, I would like to close my presentation. Thank you for attending my presentation, and I wish you a pleasant day. Thanks.